All right. I believe you can all hear me. You are welcome to this class, Mechanics Design, MED 235. Please do not send me a direct message. Let me share the screen first. Now, if you are seeing my screen, all you need to do is click on this part and you will see everyone in meeting. So you send it that way. You send it on everyone in meeting. Do not send me that direct message, except it is a matter that is personally revolving around you. So as you join this class, kindly indicate your real names and your study center, your JPTS study center. Towards the end of today's lesson, in about 10 minutes, I'll be posting assignments, real life assignments for you to try your hands on. You will do this assignment by writing it on a paper using the format that I'll be publishing on the chat box. Then you upload the snapshot of your answer scripts to the Google link that I will be posting. Let me repeat. In about 10 or 15 minutes, I'll be posting on the chat box questions, assignments that you will try your hands on for those who are in the class here. You're expected to answer those questions on a sheet of paper using the format. You must use the format that I will also be posting, indicating the course title, course code, your name, your center number, your department. Then you upload it to the Google link I will be posting on the platform. If you understand that instruction, can you type 11? If you understand that instruction, can you type 11? Adekunle Fatai, Samuel Martins, if you understand the instructions, can you go to the chat box and type 11? Okay, so we proceed. Let us look at it. The basic criteria for designing machine parts is to ensure that it preserves its operating capacity during the stipulated service life with minimum operating costs. In order to achieve this objective, a machine element should satisfy the following broad areas: strength, rigidity, wear resistance, and minimum dimensions and weights, manufacturability, safety, conformance to standards, reliability, and maintainability. Let us look at these criteria one by one. Strength. A machine part should not fail under the effects of the forces that act upon it. It should have sufficient strength to avoid failure, either due to fracture or due to general yielding. Does this mean that every machine parts will not eventually fail? No. But this is not placing a question mark on the ability of the engineer to be able to produce a strong machine parts. There has to be a balance between what is acceptable according to the social and engineering standards of a particular area at a particular time, because the International Standard Organization has a standard for all products or services that is being given out, and it is not different for the engineering profession. Therefore, while an engineer in his mind would want to create a machine part that will last forever, it is not practically possible. And from the economic point of view, it should not be so. Therefore, for a reasonable length of time, a machine part should have sufficient strength to avoid failure, either to fracture or general yielding. In rigidity as the second criteria, a machine component should be rigid. That is, it should not deflect or bend too much due to the forces or moments that act upon it. Again, this is as per the standard of a particular region at a particular time. Wear resistance. Wear is the main reason that puts the machine parts out of order. It reduces the useful life of the components. There are different types of wear. Loosely, most people will say wear and tear. These are the natural wearing away, natural easing of parts because of usage, and this is natural. However, some materials wear faster than others depending on what environment it works in. If a machine part undergoes a lot of friction, of course it will wear faster than other material that do not undergo friction. Therefore, the kind of metal or the kind of material that will be used in that environment will be quite different with the one that is used that is not in the friction environment. So there are different types of wear, such as abrasive wear, corrosive wear, and pitting wear. If you are just joining this class, if you can hear my voice, go to the chat box, state your real names and the center you are joining from, your study center. John Omotosho, Adekunle Fatai, Samuel Martin. Please mute your mics. Mute your mics. If you unmute your mic, I will yank you off this class. Mute your mic. All right, so that is where we are. In about 5 minutes or so, I will be dropping the questions. I'll be dropping it. We'll be having a real live assignment where you have to write the assignments on a paper, answer them on a paper, follow the format by putting the course code, course title, your real name, your study center name, and your department, and uploading that snapshot. You will snap the answers and upload it to a Google link I'll be posting. So be ready. In about 5 minutes, I'll be dropping that. So we are talking about, if you're just joining the class, we are in Mechanics Design Med 235, and my name is Engineer Osita Arukwe, and we are talking about the basic criteria of design of machine parts, and we mentioned them as strength, rigidity, wear resistance, minimum dimensions and weights, Manufacturability, that's a mouthful. Manufacturability, yeah, no, safety, conformance to standards, reliability, and maintainability. And we started looking at this individual criteria. We've talked about strength, we talked about rigidity, we have just talked about wear resistance, where I said that there are different types of wear that we have. There's abrasive wear, there's corrosive wear, and there's pitting wear. There is a method by which you can reduce the wear and tear that happens on materials, by increasing the wear resistance of the machine components by doing what is called surface hardening. Surface hardening. Okay. Let us go to the next criteria: minimum dimensions and weights. Minimum dimensions and weights. A machine part should be sufficiently strong, rigid, wear resistance, and at the same time with minimum possible dimensions and weights. See, this is like packing the best quality in the smallest possible way. I am very sure that in future, of course, airplanes, if you look at the sizes of airplanes, engineers are always looking at how to reduce the size of an airplane and still make it faster, or increase the size of an airplane, a jumbo jet, and still make it as fast as the predecessor. But the best thing is being able to produce as small in size of a machine part, but yet having the same efficiency as a bigger size. Why do you think phones, initially when mobile phones came out, they were as big as what you can imagine? Think about the 3310, think about the Samsung, think about the Motorola's. But now they are sleeker, smarter, smoother, thinner phones, even laptops. Those days, you'll get a laptop that is as huge as a desktop. Then there were even no desktops. The CPUs of desktop were as huge as, there was actually a computer that the CPU filled an entire room in those days. But you see, CPUs are getting smaller and smaller and smaller. You can even fit it on a phablet. Phablet is a combination of phone and tablet. So when you can create a machine part, and that is actually a machine part that is so small that it also has all the qualities of the bigger version, then you are getting an efficient system, because we're looking presently at how engineers can create smaller machines that can do bigger and more efficient work. All right, we go to the next one. Let me look at our charts. Okay, John Omotosho joining in from Abaranje. Okay, Samuel Martins joining in from Ushodi Center. Adekunle Fatai, where are you joining us from? Adekunle Fatai, what is okay? Where are you joining us from? I need to know your study center. Okay? Now, the next criteria is the manufacturability. The shape and material of the machine part should be selected in such a way that it can be produced at minimum labor costs. There is no use producing a machine that you have to spend the entire budget on, the budget of the machine itself and the budget of the whole company, just because you want to achieve that milestone. It's not practical. It's not, even though it's practicable, it's not efficient. And as engineers have always been saying, you need to have a system of operation that you have planned everything. You need to be both the engineer, both the cost person. You need to be the time person, because if you produce a machine part after 50 years, you won't even live to be able to show that the machine part works. So you need to produce a machine part, or you need your design to go into prototype as quick as possible at the lowest possible cost and at a minimum design as much as possible. So it needs to be able to be manufactured. That is the manufacturability. Safety.
The shape and dimensions of machine parts should ensure safety to the operator. There is no use producing a machine part that is unsafe. If it is unsafe, then it shouldn't even go into prototype in the first place, because one of the basic things about engineers is that you need to be safe at all times. Safety is very important. Safety very important. I remember quite well one of those times when we were in the field in an operation where we had to monitor discharge operations of STS vessels, ship-to-ship vessels on the sea. And unfortunately, the personnel for that operation weren't much. I was the only person that had to go for that operation, and I needed to transfer from the daughter vessel, which was a receiving vessel, to the mother vessel. But this was happening very late in the night at about 2 a.m., and the sea was very rough. The first thing that any engineer will do at that point is to ask, is it safe? Is it safe? If it is not safe, you do not enter into it at all. Ab initio, you will cut it off. So if you are designing any machine parts, you need to be sure that the machine part is safe for the operator of the machine. If you are turning a metal on the lathe machine and you are asked to do this without your protective glasses, it's not correct and it's not safe. Therefore, you should not endeavor to go into it. Next one is conformance to standards. A machine part should conform to the standard. Remember when I was talking about other qualities, rigidity, strength, and so on, I told us that there is a standard. There's a standard. What materials, what strength that we get in materials in region A might not be the same thing in region B. So you should know where you are producing your material, your machine parts, and which country or which area that it is being produced in, and what standards conform to that area. Reliability. It is the probability that a machine part will perform its intended function over a specified period of time that it should perform on function over its lifetime. There should be a specific limit or range of time that your machine part is supposed to work or supposed to be available for that service. So how reliable is your machine part? The machine part that A produces, is it as reliable as the machine part that B produces? Then maintainability. It is the ease with which a machine part can be serviced or repaired. Did you produce a machine part that is very difficult to repair? I remember quite well that one of the advantages that the Chinese products got over other products was that you can easily get the parts. The parts are easily attainable and they are cheaper. So you can easily get it. But parts that are more difficult to get, if you need to do a change or to do a repair on your component or your machine, if you have to ask for the parts from abroad, you see, you have to impute the cost involved in importing some of these parts. Then look at the time that this would happen. So all of these, if you impute it, you will see that most companies would prefer to go for machine parts that are easily maintained. So maintainability is very important. All right. We will be continuing with determination of permissible and actual stress in the next class. I'm going to stop here, and we'll be expecting that your assignments will be done. So I'm going to stop here. We have been studying about what machine mechanics is all about. Mechanics design is all about. We studied the criteria for the design of machine parts, and we looked at all the criteria one after the other. We're going to stop here, and I'm going to be posting the real life assignments, and I would encourage you to ensure you get these real life assignments done and submitted in the through the Google link that I will be posting. This Google link will shut after 10 minutes. After 10 minutes, they will shut down. So ensure you do this very fast and submit. The results of this will be published on all our platforms as soon as possible before the end of today or tomorrow. So I will be sending the question now. Ensure you copy the Google link quickly and ensure you do the assignment. And what is the format for the assignment? I will post the format. You will answer these questions on a paper, on an answer script, snap the answer script and upload it to the Google link where I will get it. Do this within 10 minutes. Confirm you understand the protocol or confirm you understand what I have said by typing on the chat box 11. Go to the chat box and type 11 if you have heard me and understood these instructions. Okay, if you can hear me, I have posted the questions and the link to the chat box. Number one, these assignment questions for Mechanics Design. Number one, there are different types of wear, such as abrasive wear, corrosive wear, and pitting wear. Explain all above. Number two, differentiate cutters and couplings. This is the next course we'll be going into, but I want you to do some research work. I've always told us that in JPTS, we are research students. We are into research. We are not spoon feeding. So most of you that will always ask, where is material? Where is material? You will get materials towards the end of the course, but do some research. So put your hands on these two questions. This is the way you will send, this is the format you will send the answers. On the paper, you are answering this. Write the course code, Mechanics Design, then the course title, MED 236. Then you, assignment number 1A, you write your name, you write your username, you write your study center, and please, you write your department too. You write your department too. Your name, username, study center, and department. Let me clarify this. Study center. You will also see this in the form. I've just resent it. You also see this in the form: name, username, study center, department. Then you upload the answers to the Google form, that's the Google link that is depicted there. I'm going to give you some minutes to do that, so that you will get the Google link, and ensure you do this within 10 minutes. Your time starts counting now. After 10 minutes, please do not chat me up and ask me, sir, I did not, my answer script is not being allowed. Nobody will pick it up because it's not physical. The system will automatically reject it after 10 minutes. All right, thank you very much and have a nice day. At the end of this course, this will be automatically logged out. I'll be ending the course in the next 2-3 minutes, and we will see in the next class. All right, when you join the class, even though you're already late, we've already concluded the class, assignments have been given, please ensure you join with your Zoom name and with your registered JPTS name. Send your real name with your JPTS Study Center name on the platform. All right, when you are through with the answering the questions, please submit on the Google link. In 10 minutes, it will be off. All right, thank you very much and have a blessed day.